Hi everyone, let's solve today's daily challenge, that is minimum length of string after deleting similar ends. So what is the question? Question is that you're given a string S, alright, and it is consisting only of characters A, B and C. And you are asked to apply the following algorithm on the string any number of times. So what is the algorithm? Algorithm is pick a non-empty prefix from string S where all characters in the prefix are equal, okay? And pick a non-empty suffix from the string S where all characters in the suffix are equal, okay? And the prefix and suffix should not intersect at any index. Okay, first let's understand. You have to take a non-empty prefix, all right, in which all the characters are equal. So if we see this particular test case, see, this is a prefix in which all the characters are equal, right? A, both characters are A. So also let's see this string. Here you can see the prefix will be this, right? And the suffix will be this. So for both prefix and suffix, the characters in it, right? See, for this string, the prefix is what? Prefix is B, 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 B. All the characters in this prefix must be equal. And similarly for suffix, all the characters in that suffix must be equal. Also, these prefix and suffix, they must not be overlapping or intersecting. Let's consider I had like this test case, right? I can take this as a prefix or I can take this as a prefix, but I cannot as a suffix, but I cannot do this. Take this as a prefix and take this as a suffix. I cannot overlap, right? These prefix and suffix, they must not be intersecting. Okay, so these are valid prefix and suffix because see, the only thing that matters here is taking a prefix in which all the characters are same and taking a suffix in which all the characters are same. Correct. So these are the three rules, right? Or the steps of this algorithm. Okay. The fourth one, the characters from the prefix and suffix must be the same. Okay, now they're telling us that characters in those prefix and suffix, they must be the first of all, in the prefix, all the characters must be same. In the suffix, all the characters must be same. And these characters in the prefix and suffix, they also must be same. Let's say if I had an example like this, okay, A, and let's say C, and B, correct? This is a valid prefix, right? According to the first rule. This is a valid suffix according to the second one. Right now, the fourth one says that the characters in the prefix and suffix must match. But they matching? No. A is not equal to B, correct? If it was, see, here they are matching. This is the prefix, this is the suffix that we have taken, and the character in both prefix and suffix is B only. So they are matching. So this should also be true. Then you have to delete both the prefix and the suffix. And then what you have to do is you have to return the minimum length of S after performing the above operation any number of times and possibly 0 times. Okay, so what the question have asked you to do is take a non-empty prefix in which all characters are same, take a non-empty suffix in which all characters are same, and obviously prefix suffix, they do not be intersecting at any index, and the characters from the prefix and suffix must be the same. Okay, so these four, and you have to remove such prefix and suffix. Now after that, what will happen is you will be left with a string in which you will not be able to do any operation. So you have to tell the minimum length of that string, right? So let's see, what are we being told? Okay, let's take this particular case, right? We have CA, and this is the first test case given to us. We'll come to this after this particular test case. See, we have C and A. See, I can choose this as a prefix and this as a suffix, right? Because they cannot intersect, right? So now you can see that this C and A, they're not matching, right? So there is absolutely no way for me to remove these characters. So the length of this, of the minimum length of this string that will be remaining after operations will be 2, right? Because we have performed 0 number of operations. We cannot perform any operations here, right? Now let us look at this particular string that we have taken. So see, this is a valid prefix, correct? This is a valid suffix that we are talking about. The characters are same. So we can simply delete all these characters and delete all these characters. These characters are now deleted. Now move on to the remaining part. So remaining string is now this part, correct? This is my remaining string. Now what I have to do again, I have to start trimming. See, so this is a character and this. So we have a valid suffix and prefix that can be removed from this string, right? Because both of them are equal. So prefix is what? Prefix is a, suffix is also a in this case, right? We cannot extend these prefix and suffix at all, right? So we will remove this a as well as this a, correct? Move on to the remaining part. Now the remaining part is what? Remaining part is this. So what we can do is, see, now in this remaining part, we will start from here, B, and I can extend this to this. So this is my prefix, and here I only have this suffix. So this is only valid suffix, and I can only perform operation using this, right? So I'll remove these B and this one B, right? So prefix and suffix have been removed. Now what's the remaining part? Now the remaining part is this, right? Up to C. Again, form the operation. We can perform, right? Because these characters are matching. So we can simply remove this part and this part, valid prefix and suffix. All right. Then what is the remaining part now? The remaining part now is this particular part, that is B, C, B, C, B, right? Now from this, I can only remove this B, correct? Then my remaining part will be this. Remove these C. Now look at this. This B cannot be removed. Reason being, your prefix and suffix, they cannot intersect, right? So you cannot say that, see, this is a valid prefix, definitely. Valid suffix, yes. But they are intersecting, right? We cannot have intersecting prefix and suffix. We can only remove those prefix and suffix which do not have any intersection part. Correct. So the minimum length of the string after performing operations is what? 1, because this character will be left out. So 1 we will print. So now I hope the question is clear to you. What we have to do? What is the operation? Right. Now let us look at how we can solve these questions. Right. Now see, what we are trying to do in this question is we are taking a prefix and a suffix. And there is one thing common between both prefix and suffix, right? And that is you are checking for the same character in both prefix and suffix. So what you have to do is you have to start from here, correct? So let's take this as I, and you have to start from here as the suffix, right? So see, B alone is also a valid suffix, right? B alone here is also a valid prefix, right? Although we can perform the operation any number of times, but why don't we, while standing here, right, to make things easier, we'll remove all this. Now see, the problem is, if you see, we can perform the operation a number of times, you'll say I can take B also, right? It is a valid prefix, it is a valid suffix, but in that case you'll not be getting any answer, because here one B will be left out and here you will be having A, so you will not be able to perform any number of operations. So this would be an incorrect answer, correct? So you have to check, if I go here, are the characters matching? Yes, they are matching. So you can extend your prefix up to here. So your valid prefix can be this. Keep checking, right? Keep checking until you find a character which is not equal to the current character, right? Inside of your valid prefix. So it is up to this point. So B, B, B. This is what you have to remove, correct? So you'll take your I pointer here, right? Similarly for J, what you'll try to check, this character is matching, this is a valid suffix, that's all right, but you have to see if this goes up to here, because you want what? Minimum length of string after performing operation. It is not just that you have to return a string after performing some number of operation, etc. No, right? So for it to be, minimum, you will have to check for the suffix, maximum suffix length, right? So I have to remove this suffix. So how do you go about it? Simply you're standing here, right? Keep checking if this same character matches here and here. So that way you can extend your string. So your J pointer will now be here, correct? So you have basically trimmed out this part of the string after performing the operation. In the next iteration, you will be here, you will be here. So you'll check for this character. Now this is a prefix and this is a suffix, correct? Remove that. So now my I pointer would be here, my J pointer would be where? At this particular index, correct? Now my I and J, I know where they are. So here inside of the prefix you can see that this will be a valid prefix, correct? So you will again keep checking, okay, this is P, I know this particular character is P, and I know that I can perform an operation, so I have to check how much I can extend this prefix, right? So I can extend it up to this point, correct? So my I will be here, and then I will just simply cut out this part, right? I will simply remove this part from the string. Then I'll move here. My I would be here next. Similarly, my C would be, my J would be here next, correct? And then again check how much can you extend your suffix and how much can you extend your prefix, right? So you will remove this from your string, right? So keep doing that, but up till when? Up till your I is less than J. So see, we are using what? I less than j. We are doing what? We are just taking two pointers. So that's how we are going to solve this question. We're going to use two pointers in order to solve this question, right? That's very evident also, right? Because what is happening in the question, the way the question have been framed, it makes sense to use two pointers, right? Complete sense. Now, so what you will do is basically take a while loop, right? Put this condition I less than j, and why I less than j? Because simply you cannot intersect your prefix and suffix. So you will take this and also simply check if s and I they are equal. Sorry, s of I and s of j they are equal. So the both of these conditions must be true, right, in order for you to proceed ahead. Because if they are not the same, then definitely you cannot perform any number of operations. Correct. Then what you'll do is simply, then you have to check, right? You can take this character aside. You can take this character s of I aside. Now you have to check how much can you extend your prefix and how much can you extend your suffix. So for that you can put another while loop, right? While I, again the same condition, I less than j, and this s of I, if you have, it must be matching your s of your c character. Now, so I hope you've understood what happened here, right, and what we are going to do. Now there is only one catch here, and that catch is you not necessarily, there is an edge case. Okay, now what is that edge case? Let's discuss that. Okay, so let's say you have a string here, right? Let me take this one, right? C A B A B A C, right? C A B A A and B A C it was, right? Okay, B A C. Now if you try to perform these operations, see, I would be here, correct? J would be here initially. So obviously this is the prefix, this is the suffix. You moved I and j right inside of this loop. Here we'll be doing I plus plus. Here we'll be checking while I is less than j and s of j, right? It must be equal to c. You are checking if you can extend. So using this, j minus minus happens, which means j will be here and I will be here. And for the next iteration, we'll consider this if the characters match. So if the characters are matching, you will be okay. So these are matching, but these are only valid, correct? You will not be going inside of this condition. Then you will come here, right? You will come here and you will come here. So you'll trim them out. You'll trim them out, right? Now you will be at I and j, you will be here, right? So when you are here, you can already see, okay, these are matching. But as soon as, see, inside of this loop, what is happening? You are having doing I plus plus and j minus minus, but you will not be entering here, will you be? Why? Because now I has to be less than j, right? So you'll not be doing any I plus plus or either j minus minus, correct? Okay, I is less than j, you will be doing I plus plus here, correct? Now the problem is your I will be here and your j is also standing here. So if your I and j are standing at both at the same position, then you will not move into this condition again, right? Now what we are returning, right, what we have to return, we have to return the length of the remaining string. So that, how do you get that? You get j minus I plus 1. You do simply this, right? If you have, let's say b b c, you have this, right? So this is 0, this is what, 2. So 2 minus 0, 2 minus 0 plus 1, this you have to do, correct? So these are 3, right? So this is how you get 3 from here, correct? So that is what you have to return. You have to return j minus I plus 1. But in this case, you will be returning plus 1, right? You will be returning only 1 because j and I are equal. So basically, for cases where you have to return 0, where you your minimum length is going to be 0, you will be performing all the operation. Your string will be completely empty by performing the operations, right? And that is the minimum length, that is 0. For this, you will be getting 1 instead of 0, right? So which means that we are doing something wrong somewhere. Now where is it? It's here only. You have to check here only. If I is less than j, I is less than j, you have to put an equality sign here, right? And that equality will make sure that this formula works, right? Correct? I hope you're understanding what I'm trying to tell you. You don't have to put the equality here, because here you're only checking for prefix and suffix not overlapping each other. But here, when you are inside of this, you are checking for extended. But when your I and j, they are just, but like I plus 1 is equal j, in such condition, when you have to remove this character, you have to go inside this condition, right? So how can you go inside of this condition? This is the edge case that I'm talking about, right? This is the edge case. How will you go inside of this condition? Only when your I is equal to j, right? So either you do I less than equal to j here or here, and both of them would work, right? Or ideally just put equal to sign in both of the conditions, right? So it will be taken care of. So this is what you had to like only observe here. Like a lot of you must have come up with this whole approach, but there's only this part where things go wrong, and that is the edge case for this particular problem. And the edge case appears when your minimum length is going to be 0. That is, your ith and jth character, when there is only a difference of 1 between them, they also match. So you have to return 0. But instead of that, using the formula, you will return 1. So that is why inside of this two while loops, you have to do I less than equal to j. So that is it. That is how you have to solve this question. You have to take 2 pointers. First pointer will be pointing at the 0th index of the string, and second pointer at the last index of the string. Both will be standing there. Then what you will check, first of all, this condition must be true, I should be less than j, and second of all, those characters at those particular position must be matching. Only then you will check, okay, I extend this prefix, so can I extend this suffix? And how do you check to extend the prefix? You will be iterating inside of this while loop, and for extending the suffix, you will be iterating inside of this while loop. Now there is this edge case that you have to also keep in mind, and that is when this condition becomes true. Right now you might ask, why are not we taking care of it here? Right, why are not we are not taking care of it here? See, I that is why I took this particular case. Here what happened was, I came here and j came here, correct? I and j are equal, right? So you might say that if I can simply check if I is equal j, then I can simply return 0, right? And if those characters also match, like si must be equal to si of j, then I can return 0. Otherwise I will return this. But if you see here, your I and j are actually pointing to the same character, but the minimum length has to be 1 here, right? Because these are intersecting prefix and suffix. But inside of this is handling your prefix and suffix, right? This particular while loop. But these while loop are handling the prefix and suffix that you're considering, right? So here, what happened is I became equal to j, but for like both are the same prefix and suffix, but you have to check for different prefix and suffix that you are doing inside this while loop. And that is why you cannot put this condition, you will get the wrong answer. So you have to put the I less than equal to j here. You have to check, can I extend this? First you are checking, right? Your prefix is starting from here. You can say this is like this, right? Your prefix is starting from here. You are checking, can it be extended? Oh yes, it can be extended. And your suffix is standing at here. Can it be extended? Yes, it can be, but I cannot now because I is already here. So that is the thing, right? So you cannot use this condition, because for this particular test case, right, for such cases where the minimum length is going to be 1, right, where this should be the answer, you will actually be returning 0, which is incorrect, right? So that is how you have to basically solve this problem, and that is how you have to like, this problem had this edge case and was not easy to come up with. I guess that's where a lot of you made mistakes, but yeah, that is what you have to take care of. Otherwise the problem was fine, I guess. So now let's discuss the time and space complexity. The time complexity is simply going to be big of n, because you're only iterating inside the string, right? And for these while loop, what are you basically doing? You're just incrementing your I is moving here, j is moving here. So you're essentially only iterating in linear time. You're like just iterating linearly. So your time is big O of n, and space obviously is constant, right? So this is time complexity, this is space complexity. So this is how you have to solve this question. Now let us go ahead and look at the code. See, that is all we are doing. I is equal to 0, j is standing at the last index n minus 1, and here you are checking for non-intersecting prefix and suffix. But here why have we used that equal? That equal is to check the extendability. See, you will never ever go inside of this condition, right? First of all, you will never ever go inside of intersecting prefix and suffix if your I is less than j, right? So that is why for such cases where, for this particular test case we saw that b has to be left out, right? That is why inside of the loop you can have an equality sign, but outside you cannot check the condition like this, because that will give you 0 for this particular test case also, right? So that is it. So here you are checking for non-intersecting prefix and suffix, and then you are checking inside of these two while loops the extendability of those prefix and suffix. How much can you extend and then remove? Then you are removing that, right? And simply return j minus I plus 1. And this equality will help you take care of the edge case where your ith and jth, the difference between I and j pointers is 1, and also I and j pointer characters are matching. So that is the edge case, and minimum length in this case would be 0, right? So that is how this equality is going to help you, and you can simply return j minus I plus 1 in that case.